Hi everyone, my name is Isiki. I am a lecturer from Faculty of Electrical and Electronic Engineering. So in this video, we are going to find the electric field which is from a line charge distributions. Okay, so now let's look at the questions together. So we have to find the electric field at the position P. Okay, if there is a line charge distributions, so this is the rho L of the line charge, okay, along the axis y from -5 to 0. Okay, so the first step will be we draw this. Okay, we draw this line charge. Okay, so I will draw my axis. Okay, so this is x, this is y, and this is z. Okay, since it is coming from negative, okay, so negative, so I extend my negative y-axis. So if this is y and it stopped at the origin, okay, so this is your line charge. Okay, so you have to find the electric field at the positions -1. Okay, so -1 basically is here, -1, and 2 might be here, and 3, so it's here. Okay, so this is your position P. Okay, so we know what is the length, right? So from -5 to 0. Okay, so we are going to start our calculations by first finding our point T. Okay, so point T will be a point that is along the axis that you have your line charge. Okay, so this is your line charge and your line charge is along the axis y. So all the coordinate on the axis y will have an x-axis of 0. Okay, and the z-axis is also 0. Okay, so y we have no idea. Okay, so for the y coordinate we have no idea, so we have to refer to the y coordinate of the point P. So in this case the y coordinate is 2, so our point T is 0, 2, 0. Okay, next we find these distance vectors by subtracting, okay, the position vectors -1, 2, 0, okay, with 0 to 0, point T. Okay, so as the result we get -1 and 0 and 0. Okay, so the distance between the point T and also the point P is just 1 unit. Okay, and the distance vectors, okay, unit vector is -x. Okay, -x. Next, we will look for this alpha 2 and also our alpha 1. So let me redraw again my line charge. Okay, so my axis y here. Okay, so it's from 0 to -5, right? 0 to -5. So this is 0, this is -5, and this is point A and point B. Okay, so according to my definitions of point T, it is over here is 2, right? Okay, so this is my point T, and I am going to connect it with my point P. Okay, so just connect them. Okay, just connect them. Okay, just connect them. Right. Okay, so point alpha 1 will be from PT to PA. So this is alpha 1. Okay, so you can see this alpha 1 is in the anti-clockwise directions. Okay, so anti-clockwise direction means that the angle is a positive angle. Okay, as well as this point for as well as for this alpha 2. Okay, it is also anti-clockwise, so the alpha 2 is also a positive angle. Okay, positive angle. Right, so now let's find this alpha 1 and also alpha 2. Okay, so for the alpha 1, so this is my alpha 1. So this is my point T and this is my point P, and in fact the length is just 1 unit. Okay, and from point T to point A, okay, so here is 2 unit and here is -5. Okay, so we have 7 unit here. So tangents, okay, alpha 1 is equals to opposite over adjacent. So our alpha 1 is tangent 7 is 1.43 radians. Okay, and the angle is positive for alpha 1. Okay, then we move on to alpha 2. Okay, so alpha 2, we have point P here and point T here. The length is 1 unit, and over here is the point B. Okay, so you can see this is 0 and this is 2, so the length is 2 unit. Okay, so this is your alpha 2. So tangent alpha 2 is equals to 2 over 1. So your alpha 2 is equals to tangent 2 is 1.11 radian, is a positive angle. Okay, because it is anti-clockwise directions. And now we replace into formulas. Okay, so the rho L, okay, the rho L is negative 6 nanocoulombs. Okay, negative 6 nanocoulombs over 4 pi epsilon naught r. Okay, r. So we are required to find the value r, which is 1 in this case. And then minus sine alpha 2. Okay, 1.11 plus sine alpha 1. Alpha 1 is 1.43. And behind we have to fill up the unit vector r. So unit vector r is negative x and plus cos alpha 2 minus cos alpha 1. Okay, so over here we have to look at the axis that we have our line charge. So in this case, our line charge is positioned along the axis y. So over here we have to replace with y. Okay, so we can start the calculations. Negative 6 nano. So it's negative 53.93. Okay, so minus sine so here I have 1.094 negative x and plus (0.30 y so here is 5.07 x minus 16.18 y. Okay, so this is the electric field at the positions P. Okay.